Hello, everybody, and welcome to our new book. It's yellow and it says Expressions and Equations 2 in the top corner here. So the first thing we're going to do is go to our word bank. And consecutive integers. It's always the next whole number. Integers are whole numbers, including 0, including all the negative numbers. The next whole number. It might be the previous or the next, but they're next to each other. So for example, 0, 1, 2, 3, 4 are consecutive. Distributive property is when you multiply. It's important that you remember you have to multiply everything in the parentheses by what's outside. So you have more than one set. It's like sets. So the number outside tells you how many sets you have. Sets you have. So for example, it'll look like this. For example, you have 2 of 5 minus 4. So you have 2 sets of 5 minus 4. So you have 2 times 5 minus 2 times 4, which is 10 minus 8, which is ultimately 2. Now you're going to say, well, I can do 5 minus 4, which is 1, and multiply it by 2, and that'll give you the same answer. And that's true, but distributing means you're going to multiply. So that comes into play later when for symbols. We're having symbols, not numbers. An equation are 2 equal expressions. So an equation always has an equal sign in the middle and then something on the left side and something on the right side. Left side, right side has to be equal to each. So for example, I can say that 5 plus 3, the value of 5 plus 3 is the same as the value of 12 minus 2. No, wait, 5 plus 3 is 8, yeah. 12 minus 4, right? Yep. Want to make it equal. So if that's true, you have an equation. So an equation, left side has to balance or equal the right side, the value. So think of it as a scale. If you have ever seen those old-fashioned scales, that's called a fulcrum in the middle, and then you have a little bit hanging here and a little bit hanging there. And if that scale is balanced in the middle, then you have equal weights, right? So if you put a weight on this side, you got to put the same weight on the other side or it won't balance anymore. So think of this line as your equal sign. Yeah, so whatever's on the left side, you better have the same amount on the right side, the same weight, or the scale won't balance, and then it's not an equation. An expression is almost like an equation, but it really doesn't have 2 equal sides. Expression doesn't have to be balancing out. So it's a combination a combination of numbers, comma, symbols, like variables. We call them variables in algebra, which are usually letters, and operation signs like plus, minus, multiplying, dividing. Those are the 4 signs we know what we can do with numbers in arithmetic. So we have a combination of numbers, symbols, which are called variables, and one or more of these signs. Equivalent expressions is like an equation. Yeah, like equation. The word equivalent means same. Equation. Okay, so for example, 2 equal expressions. So for example, remember I talked about symbols. You can use any symbol because the symbol means a number, but you don't know that number. So it has to be the same symbol for the same number. So for example, if I say 15 plus a heart, then that would be the same as 7 plus 8 plus a heart. That's the same value. The heart is your symbol that means the same number in both cases. So now you got the same value, right? Because 7 plus 8 is 15. Okay, so 2 equal or equivalent expressions. Like terms, you're going to hear a lot about like terms from here on out. A term is like a number or a variable or a symbol that's separated by a plus or minus. So terms are separated by a plus or a minus. Those are the symbols that you can, those are the operation signs you can use when it comes to terms. Now, like terms have to look alike. They have to be the same, okay? So, like terms, like the word like says, have to look alike. For example, heart and 2 hearts are like terms because they're the same. Do you see? Yeah, because they have the same symbol. Or 5 times the number x and 2 times the number x are like terms because they have the same symbol. Or 6 and -2, or let's make it -3, are like terms because they're just numbers. All numbers are like terms. And here's the most important thing. Well, I'm going to put that under the word of your choice. So I'm going to leave that as like terms now. A variable is a symbol, and it's usually a letter in math. Whoops. Like the most common is X or Y. That stands for a number. Specific number. Your job is most likely, a lot of times we have to find that number. The same symbol means the same number. So if I use symbol heart and heart, it has to be the same number. In the same problem, it's the same number. In the same problem is the same number. Okay. So a symbol takes the place of a number. And then word of your choice, I want to use combining like terms. You'll hear that a lot. Combining like terms means you add or subtract them. Remember, like terms are the ones that are alike. So you can only add or subtract. Important. Remember, adding is plus, subtracting is minus. Like terms. Not all terms can be added and subtracted. No others. None other. Okay, super important. You can multiply or divide. That's later, but I want you to know you can multiply or divide them, but you can only add or subtract the ones that look alike. Super important, because my students, like a runaway train, they want to add and subtract everything, but you can't. So for example, I like the heart. So if you have 5 hearts plus 2 hearts, those are like terms, right? Then you say 5 plus 2 hearts is 7 hearts. See how you can add them? Because they're like terms, right? But if you have 5 hearts plus the number 3, you cannot add them because they are not like terms. Because they are, so I'm going to box this answer, not the same. Okay, so don't add 5 hearts plus the number 3. They're not the same, so you cannot add them. Okay, put a big question mark, highlight, whatever you can do to remind yourself this is important. Okay. Okay, so that page is done. You need to make sure that's all completed when I look at your textbook. All right, you can always rewind and stop. We're now on, I'm going to make this an extra credit page, page 1. If you can figure this out, you're good. So I'm going to make that extra money for you. Not money, but extra credit. How about 5 points? If you can figure it out, you might have extra time on a day when you're not doing anything and you're like, oh, I'm going to try it. Okay. I'll make it a separate assignment. Okay, here's the problem. Here's the question. I have to look it up. So you're ferrying people across a lake and you have one boat. So I gotta write it up, guys. I have to find it. Oh, there it is. The lake problem. So there's a canoe. A canoe that holds one child alone. I'm going to put that under caption. One child alone. or 2 children together. Kind of weird, but or 1 adult alone. And you, here's the problem. There are 6 adults. Six adults and 2 children that need to cross the lake. They all have to row. They all can row. So going around the lake doesn't count. What is the least number of trips needed? The least. Remember, the word least means minimum number of trips needed. Question mark, okay? And here's another thing. Everyone can paddle. Everyone can paddle. And it's the only way is to cross the lake. You can't go around it. So if you decide to tackle this, draw the canoes, and when you do your visual, draw a canoe and put a C for a child, or 2 C's if you pack 2 children, or a capital A for an adult. So you can show and then draw, you can have this whole space here to work it out. So you can say first run, 1 child, go back, get an adult. You can use arrows to go back and forth to show which, so you start, they're all on this side, and then you're going to ferry them over across, go back, ferry them over, and who's in your boat? That's what it is. Who's in your boat each time you cross? And so you can figure out how many trips it will take to get everybody over the lake. Okay, hopefully you understand that. And we're going to skip this part. So write skip. Oops, come on, my little writing machine. Gets sometimes so temperamental, that machine. So the lake problem, the continued part, we'll skip. And then next page is page 3. Okay, so page 3 will be notes. Gotta find my book again. Notes. Make sure you write this on top. Okay, equivalent expressions, introduction to cups and counters. So cups will look like that. Counters are either that or that. Okay, so a cup is like a V. And I'll explain that to you. Okay, we will apply properties, which are rules of arithmetic, which is math, a fancy word for math, to generate equivalent same expressions that include integers. Remember, integers are whole numbers, including 0, including all the negative numbers. We will write numerical expressions. Numerical expressions have only numbers, no symbols. To represent geometric patterns, describe patterns in words, and generalize these patterns using variable expressions have variables or symbols in it, symbols and numbers. Okay, so we already did our word bank, good. In algebra, we typically write expressions horizontally, which is flat, or as fractions, right? A over B number like that. Rewrite each arithmetic problem below as an expression horizontally on one line. Do not compute. Well, that's good. So we're going to rewrite it 23 plus 46 plus 54 is horizontally. This is called vertically. And this is horizontal. So that way, okay? This is a minus problem. When you subtract, the order matters. Not when you add, but when you subtract, you start the top minus the bottom. This is a division problem. The order matters. You do 451 divided by 19, not the other way around, okay? So rewrite problem 4 using fraction notation. Okay, the top is your number under the house or in the house, 451 divided by 19. That's how you write it, not the other way around. Order matters here and here, not when you add. And when you multiply, it doesn't matter either. But when you subtract and divide, the order matters. Otherwise, you get the wrong answer. Write an expression for each verbal statement. There are 6 puppies and 8 kittens. Write a numerical expression for the number of puppies and kittens. 6 plus 8. Notice numerical expressions are just numbers. There are P puppies and K kittens. Write a variable expression. Now we have variables. P plus K. Those are not like terms, by the way. Okay. Shira has 4 ribbons. Raza has 6 times as many. That's not adding or subtracting. That's multiplying. Write a numerical expressions for. Okay, I'm going to show you how you write multiplying in higher math. We're not using this anymore. So I'm going to say nope. So we write either 4 times 6 or 4 parentheses 6 or 4 parentheses, both in parentheses. All these mean the same thing. Multiply. Okay, so most likely you'll see me write it like that because I don't do the dot hardly ever. Most likely I will write it like that. Okay, and this is too much work. You got 2 sets of parentheses when you really only need 1. Okay, so let's look. Shira has n ribbons. Raza has 6 times as many ribbons. It's a multiplication, n times 6, or as we write it in algebra, simply 6n. This is how you write it. This means multiply. So when you see this, this means 6 times a number. So a number n by 6. So this right here is the same, but we write it like that. Okay. All right, next page. This was page 3. And this is also notes. And this is called the distributive property, which, yeah, so distributive property, you will hear a lot about in math. So make sure you pay attention and take good notes and try your best. Distributive property, highlight it, put arrows, study, something like that to help you remember to look at it. Okay, this table shows the number of hours who are worked at the pizza shop. 4 off, Friday 4 hours, Saturday 6 hours, Sunday 6. Notice 2 groups 6 and 2 groups of 4, right? Yep, that's what distributive, it's groups. So you're looking for groups. Okay, circle all expressions that could describe the numbers of hours she worked that week. 4 plus, yep, that one. 2 times 4 plus 2 times 6, yep, that works. We could add 4 plus 6 and then multiply that by 2. By the way, this is what it looks like, distributive property. And this one as well, 4 plus 6, you have two groups, different groups. So see, this is one group. Same thing though, you can group the same thing like that. Nope, not that one. 4 plus 6 times 2, yes, 2. If you look, the value is in any case, is in all cases 8 plus 12, 20 hours. So that's not 20, right? So we're going to cross this one out. All the others are 20 hours. Okay. The distributive property illustrates equivalent or same expressions where one is written as a product, which is multiplying, and the other as a sum. Notice multiplying, and here it's all sum, right? Sum, product. This is also a product because we're multiplying 2 times whatever is inside the parentheses. This is a product because we're multiplying everything inside the parentheses times 2. Choose two equivalent expressions to illustrate distributive property. Okay, let me see what we got. So I chose 2 times 4 plus 6 is equal to 2 times 4 plus 2 times 6. This is distributing, meaning you're multiplying everything in the parentheses by that number in front. Okay, you're multiplying everything in the parentheses by the number out front. Draw these bows when we do this because you're going to remember that you have to multiply both parts. Both parts. Because a lot of students will overlook that. And now we're going to fill out this very, very complicated table. But I'm going to give you the example, and your job for homework is to do it yourself. Expression written as a product, which is 5 times. There's an invisible times button here between. Value of the expression as a product. It's 5 times 2 plus 7 is 9, which is 45. So now, okay, so the number 5 will be twice. That number in front is the part that's twice. So we have 2 plus 7. And then over here, value of the expression as a sum. 5 times 2 is 10, plus here comes the sum. 5 times 7 is 35, which is 45 as well. So now we have to, I'm going to do this one first. I'm skipping this for right now. 7, so now that's 4 times 7 minus 5 is 2, which is 8. The 4 gets distributed, right? Remember? So 4 times 7 minus, notice this is a difference, 4 times 5. And then as a sum, we have 4 times 7 is 28, minus 4 times 5 is 20, and that's 8 as well. So I'm going to try this one next, okay? 6, so the 9 gets distributed. 6 times 9 plus 1 times 9. No, sorry, that's the wrong slot. 6 plus 1 is 7 times 9 is 63. And as a sum, we have 6 times 9 plus 1 times 9, because I'm distributing it. Think of distributing like a distributing center that has trucks leaving and coming, distributing the goods to all the Walmart stores. Distribute. 6 times 9 is 54, plus 1 times 9 is 9, and that is 63. Now we're going backwards. This is going to be hard. So the number that's twice is the number in front, okay? So and the number that's here we add. So 5 times 6 plus 2 is 8. It's 40. And so the number 5 that's twice is only once all of a sudden, right? And you have 6 plus 2. And then 6 times 5 is 30, plus 2 times 5 is 10, is 40. Now, I'm not sure if this exercise is more confusing or helpful. Hopefully more helpful. I'm not sure. This is the book. So the number that's twice goes in front. 4 minus 3. So we have 5 times 1. 4 minus 3 is 1, and that's 5. And here we have 5 times 4 is 20, minus 5 times 3 is 15, and 5. Okay, so that's that table. If it's confusing to you, don't fret. I want you to know how to get from the beginning to here without all that in the middle. You can just do 5 times 2 plus 5 times 7 and jump the middle part. Ignore these 2 middle columns if you're getting good at it, or if you're understanding it already somewhat. You don't need to do this all the time. This is just kind of to give you extra insight what's really happening, okay? But you can go from the first and jump to the last if that helps you. At Papa's Pizza, the variable expression P plus M represents the cost. So these are our symbols or variables. Represents the cost for 1 order of a slice of pepperoni pizza, which is probably P, and a medium drink, which is M. Write expressions for the cost of 2 orders as a product. So I have P plus M. I'm ordering pepperoni plus a medium drink, but I'm having 2 of those, right? 2 sets. As a sum, P plus M plus P plus M. I think that's kind of what they want. Or you could say 2P plus 2M. Okay. Papa's Pizza charges $3 for a slice of pepperoni pizza and $2 for a medium drink. Substitute these values into both expressions above to verify they're the same. So 2, I'm taking that expression that I came up with, and P is 3, right? And 2 is M. So 3 plus 2 is 5. 2 times 5 is $10. Okay. And then the second one is this one, 2P plus 2M means 2 times 3 plus M is $2. 2 times 2 is 6 plus 4. It's also $10. So they are equivalent. Yes. Okay, now our next page is page 5, cups and counters. Introduction to cups and counters. Now this is a way to help you combining like terms. Eventually you will not do that. Eventually you'll drop this little help and do it on your own. But until we're going to try this, record the meaning of cups and counters. So a positive counter looks like a plus and it means +1. A negative counter is a minus and it means -1. A cup is a value, or I should not say means, value. I want to write value here. Value, and same here. And a cup, the value is unknown. It's a variable. It could be anything. And it's usually denoted with an X. Okay, so X is usually our variable or our unknown. Okay, so let's make a build, draw, and write expressions. So a +3 is 3 pluses. Yeah. A -2 is 2 minuses. A 3x is 3 unknowns. Yeah, 3 unknowns. X plus 3 means an unknown plus the +3. X minus 3 means you have 1 unknown and 3 negatives. And 2x minus 3 would be 2 unknowns, 3 negatives. That's how you build these. And now we get in number 8 is the, oh, no, it's not moving. Huh. Come on. Is it frozen? My little page, there you go. Number 8, we're going to make groups. Remember, distributing means grouping. You got unknown, 1 unknown, 2 pluses, 1 unknown, 2 pluses. Notice the groups are the same, right? Each group is the same. So you got 3 groups of the same. Has to be the same. So you can say I have 3 x plus 2, or I have 3 x's, right? 1, 2, 3 plus 6. So these are the same. You'll have 3 groups of x plus 2, or you can write it like that. So these two are equivalent. Okay. So the distributive property, 3x plus 2, when you multiply it out, remember the little bows, is 3 times x plus 3 times 2 is 6. See how they're the same. Okay. Number 9, I'm going to make that your homework. You're going to build and draw, same as above. Okay, so you're going to do homework here and homework here. I'll do number 15. So we need to adjust our top. Oh, I haven't written anything. Notes plus homework. I'm going to do number 15. In number 8 above, you showed that 3 times the group x plus 2 is the same as 3x plus 6. Verify that these expressions have the same value when x is 4. So I'm plugging in for every x the number 4. So I have 3 times 4 plus 2, which is 3 times 6, which is 18, and 3x plus 6, 3 times 4, because x is 4, plus 6 is 12 plus 6, Remember, multiplying before adding is also 18. Yep, checks. Yeah. Next, we're going to test it when x is -4. So I'm using the same expression. 3x is -4 plus 2. And that is equal to 3. -4 plus 2 is -2. And that's -6. And the second expression, 3x is -4. And then plus 6. 3 times -4 is -12, plus 6 is -12 plus 6 is also -6. So they're equal. Page 6 is notes and homework. So this is the important page study. This is called notes and homework. Study this. It's important. Okay, important that you learn this. Equivalent expressions. Remember, equivalent means the same, right? We're skipping this part, but we're going to combine like terms. This is the super important part that if you grasp that, your life in math classes will be so much easier. Combine like terms. Remember, like terms are the ones that are either symbols, the same symbols, or numbers. You cannot combine unless add or subtract, unless they're those types of symbols or numbers together. Okay, let's try this. X, here's our expression. X plus 3 plus 4x plus 7. So you can do cups and counters. You can draw 1 cup for that, and then 4. These are 4, right? 1, 2, 3, 4. And then you have your numbers, +3, 1, 2, 3, and +7, 1, 2, 3, 4, 5, 6, 7. So 1, 2, 3, 4, 5 cups means 5x. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 plus 10. This is the answer. Do not add 5x plus 10. They are not like terms. You can also do it like this. Anytime you see a symbol, put a 1 in front and there's no number, count it as 1. You can also group it together. 1x plus 4x is 5x. Plus 3 plus 7 is +10. You can do it this way, or you can use cups and counters. Now, if you're not good at this, I'm going to tell you to use cups and counters. If you get it and you're good at it, you don't have to do that each time. But for this exercise, we're going to do it. Here's our next problem. In other words, this expression is the same as this one. Wouldn't this one be a lot easier to deal with than this lengthy one? That's why we combine like terms. Next one, 4x minus 3 minus 3x. Minus, we're subtracting, plus 5. Let's do cups. I have 4 symbols, 4 cups. But then I'm taking away 3 cups. So when you subtract 3 cups, you're not adding more. You're going to take away 3, right? Minus 3x. Cross them out. That leaves you with 1, right? 1 symbol. And then we have minus 3, 1, 2, 3, and positive 5. 1, 2, 3, 4, 5. These all cancel out. Gone, 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 plus 2. This is our combined answer. So this expression is the same as this one. You can also do it like this. This is the alternative. 4x minus 3x minus 3 plus 5. You can group them together. 4x minus 3x is 1x, or x. Negative 3 plus 5 is positive 2. This is the same way here, okay? This or that. This or that. However it works for you, but you got to get it right. Okay, one more, actually a couple more. This is lengthy. 3x plus 2 plus 3 times the group x plus 2. Remember, this is a times, but it's not there. So let's draw it out. 3x plus 2. Oh, this is not a 3. This is not 3 pluses. This is 3 groups of x plus 2. Yeah, 3 groups of x plus 2, which is that. So now let's count it. So now we got 1, 2, 3, 4, 5, 6, 6x, 1, 2, 3, 4, 5, 6, 7, 8, plus 8. Remember this, I should put that, I'm going to go back to the previous page and use my counters. We're using this, but it means that. Okay. Okay. Oh. All right. So we're done. Oh, we're on the next page. So we're here. Number 6. I got one more, guys. Giving you plenty of examples. Remember, we're not adding 6x plus 8 is not. So I'm going to put a big no. It's not 14x. This is wrong. So do not do that, okay? Because they're not like terms. So stop yourself, okay? And we're on number 6. So all right, 3x plus 2 plus 4 set of x minus 1. This is not a 4 like 4 pluses. This is tells you how many of these sets you got. 4 sets of x minus 1. That's what this means. Okay, so let's count. 3x plus 2, x minus 1, 4 of them. Yeah, 4 sets of x minus 1. 1, 2, 3, 4. So now we got 1, 2, 3, 4, 5, 6, 7. 7, we change it back to x. 1, 2, these go away. Minus 2. Okay, so these were the examples of cups and counters. Now we're switching gears. It's going to tell you, the question is evaluate. Whenever it says evaluate, you're plugging something in. Evaluate each expression when our x, now they're giving you a number for x. X is 2. They're giving us the number for 2. Evaluate means substitute. And you're going to come up with a number answer. Okay, evaluate. So let's try this. I got 4 x's. This means 4 times x plus 6. So for x is 2. So I have 4 times 2 plus 6. Multiply first. 8 plus 6. 8 plus 6 is 14. Now, the big Kahoot problem. This is huge. We're doing the same thing. We're substituting or evaluating when x is 2. Here's the question, 4x plus 6. It's huge. You're going to be like, oh my gosh, plus 3x minus 8 minus 7x plus 2. So this is an expression. It's not an equation. We don't have an equal sign and something on the other side. Now our job is to substitute for every x the number 2. So it's a times. 4 times 2 plus 6 plus 3 times 2. So for every x gets a 2. Minus 8 minus 7 times 2 plus 2. 4 times 2, you multiply first, plus 6. 3 times 2, 6, minus 8. 7 times 2, 14, plus 2. And then you go from left to right. 8 plus 6 is 14, plus 6 is 20. 20 minus 8 is 12. 12 take away 14 is negative 2. Negative 2 plus 2, the answer is 0. So I think you can do this yourself, I hope. I'm going to make this homework. Build and draw. So 2x, I'll just do 1 plus 1x minus 3 is 3x minus 3. That's what you have to do. And this is homework. For these, I would not draw 12 and 13 cups, just combine like terms. Do it that way. 12 plus 13 is 25x plus 10. That's the answer because they're not like terms. You stop right here. Okay, when the numbers are really big, I would not draw them out anymore. Make sure you insert a 1 when there's no number in front. Okay, if it's no number in front, put a 1. And then just add all your x's and all your numbers. So you can regroup them. 15x plus 1x minus 4x minus 5 plus 25. So you need to group your x's together and your numbers. How many x's, how many numbers? And here you can distribute. Let's see if you can figure that one out. 14 x's plus 14 ones is 14 minus 11x. So 14x minus 11x, and then plus 14. So how many x's do we have? Okay, finish that up. This is page 6. And then next page is homework. And then we have the border problem. I'm going to stop here because it's getting too lengthy. So I will do that border problem next time. And then we're going to start with solving equation balance. Okay, so up till here is, and I know I'm going to skip this page. But we're going to do this page. All right, good luck to you guys.